learning how to split a fraction into some of its parts. Partial fractions means splitting up a fraction into smaller parts. It means we are going to go back larger fraction into two or more smaller fractions. So let's see how it's done. In this example, we have x minus 1 on top of a quadratic. If you look carefully, the quadratic in the denominator can be factorized. So that's the key to answering this problem, to factorize the denominator carefully and correctly. Once we've factorized it correctly, then we will be able to write it as two fractions. One of those fractions will have a factor of x plus 3 in the denominator, and the other fraction will have a factor of x plus 1 in the denominator. Yes, we don't know what capital A and capital B are, but we can figure them out because we do know of the laws of fractions and how we added fractions. How did we add these two fractions? Let's cover up that left hand side, and let's pretend that we are just adding these two fractions on the right. We would have to cross multiply them, don't we? We would have to cross multiply to get a common denominator, and we would have written the denominator only once, wouldn't we? Once you've done these two steps, what you should recognize is that the denominators of this fraction here is exactly the same as the denominator of the factorized form of our question. Therefore, we can ignore the denominators and simply equate the numerators with each other. That is, those two blue boxes. You can equate those two blue boxes and write them like so. Now, our task is much easier. All you have to do is multiply out the brackets. Now, as you see on the page, I've already labeled this method 1 because expanding brackets and equating coefficients is one way of solving it. So let's go through it. Once you multiply the brackets, you collect like terms with each other. That means you can factorize the x out of a and b, out of ax and bx. So you'll have a plus b in front of the x. This is called coefficient of x. What's on the left and what's on the right need to match up. Coefficient of x on the right is a plus b, and the coefficient of x on the left, although you don't see it, is an invisible 1. So a plus b is a 1, and the constants here is a plus 3 on the right, and the constant on the left is negative 1. Therefore, they have to match as well. Once you've written these two equations like so, you go ahead and you solve them simultaneously. After all, we were looking for capital A and capital B. Now, there are many ways to solve simultaneous equations. I've chosen to take substitution. Once you solve it by substitution, you end up with b to be negative 1 and a to be 2. Now our task is not finished. Once you found capital A and B, you will have to write 2 where a is. That means that we have to write 2 on top of x plus 3. And because b is a minus 2, sorry, b is a minus 1, we will simply write minus 1 over x plus 1. We've solved the problem. I guarantee you, if you add these two fractions, or rather subtract them one from each other, one from the other, you will end up with the original question that we were asked to do. Now, I'm going to use the same example and show you yet another method. The first two steps are the same. You still have to go through the cross multiplication and come up with this expression here. But then now you can use substitution for eliminating x. You still match these two blue boxes with each other and write x minus 1 equals to a times x plus 1 plus b times x plus 3. In this method, you can look at the first bracket and ask yourself what number for x or what value of x will eliminate this bracket or make it 0. To make this bracket 0, we can choose x to be -1. So we can take the fact that, well, we can assume that x is -1 and substitute it in both left and right. Of course, this bracket will be 0, so we only need to deal with 3 minus 3, 3 minus 1, which is a 2. So 2b must be -2. Okay, that tells us b is -1, which matches with the answer we found earlier. Then we can ask ourselves what number for or what value of x will make the second bracket 0. Think carefully. This bracket here, x can be what? X can be -3. So we assume that x is -3 and substitute it on the left as well. -3 minus 1 is a -4, and this bracket will be 0. Therefore, -2a is equals to -4. Dividing by -2 will give us a is 2. This matches exactly to the answer that we found earlier. So a is a +2 and b is a -1. As I said, just like I've written by hand on the top of the page, we do need to substitute the values of a and b into the assumption that we made. We assumed that we could split it up into two partial fractions, and we did. Okay, so let's look at yet another example. In this example, we have three factors in the denominator. Luckily, they've already factorized the denominator in this question. So we do need to perform some. We can check whether can we factorize the numerator. That's not necessary